Okay, continuing with Chapter 6 on the final study guide for Math 110. Number 26 asks you to do an application problem where you have a basketball court. It tells you some clues about this basketball court, that it has a perimeter of 92 meters, and then a clue about the length and the width. The length of this basketball court is 18 longer than it is wide. And from that, we're supposed to use those clues and find out the length and the width of the court. So we need this formula that the perimeter of any rectangular figure is 2 lengths and 2 widths. And that makes sense if you think perimeter means distance around the outside edges. So there's 2 of these that's the same, 2 lengths and 2 of the widths that are the same in a rectangle. So using this formula, we can plug in the perimeter of 92 meters for P, and that equals 2 of the lengths plus 2 of the widths, which I don't exactly know either one of those dimensions. I don't know. I know that the length is 18 longer than however wide it is. So if I let the width be the unknown, just W or whatever letter you like, then the length will be that plus 18. So then I can represent it algebraically and do an equation. 2 of the lengths we're representing with W plus 18, plus 2 of the widths, which is just W. Now we have a solvable equation. You know, if we get an equation in just one variable, we can do our algebraic steps to solve an equation. So we need to distribute the 2. 2 is multiplied by each of those, so that's 36 and 2W. I have some like terms this time, 2W and 2W. They're both on the right side, so we can combine those and say 4W's. So I have 92 equals 36 plus 4W. All right, so once you simplify each side down as much as possible, then your goal is to get that variable solved for, to get it alone. If you have variables on each side, as we've seen in some of the other problems, you have to get those together, throw some across the line, pick a left or right side. But here it's the only variable term, so we're good to go. So we want 36 over to the other side. So minus 36, since it's a positive 36, minus 36 from each side. So 92 minus 36 is 56. So 56 is equal to 4W. Okay, the last equation solving step is always to divide by what's with your variable. The 4 is multiplied on the W, so you divide out 4. 4 divided by 4 is 1, or 1W. Do the same thing to the other side to keep the balance. 56 divided by 4 is 14. So now we know the width of this basketball court. The width is 14 meters. We're talking about meters here. And then the length is 14 plus 18. Whatever 14 plus 18 is, I think that's 32. So 32 meters, 14 meters. Double check is 14, 14, 32, 32. Should all add up to be the perimeter of 92 meters. All right, moving on to number 27. Another equation solving word problem application for algebra. It says that we've had our meal and we've already paid the total bill. And that is the key on this one. Make sure you read it carefully. It says the cost of the meal, including the tip, the total cost of this meal that we ate was $17.40. Now here's the question. If you put a 16% tip in that price, how much did the meal cost before the tip? So a lot of times students will try their best to take 16% of this number, and that doesn't work out because you paid 16% tip on the price of the meal before that was added together. So you can't take 16% of this base. That just won't work. So what we have to do is kind of think back, and if you use the algebra, this helps us. If you let X be the price of the meal before you add it on your tip, that's what we're trying to figure out. How much was this meal before the tip? So I'll let X equal that. Then I added 16% was times that number, whatever the price of the meal was before the tip. So 16% or 0.16 multiplied onto that would be your tip. And now, X, the price of the meal, plus 0.16X, those two values adds up to 1740. That's the equation we need to solve. All right, think of this X as being a 1X, so you really have some like terms on this left side. 1X line to be 1.16x equals 1740. So the trick here, you wind up dividing by 1.16 to solve this. 1.16, just that algebra step of dividing by what's with the variable, leaves us x equals 1740 divided by 1.16 should give you, have that on me real quick, should give you $15. Comes out even $15. And then you can check it out. If you had a $15 meal and you put a 16% tip of that $15 on it, it should add up to be the total cost of $17.40. All right, so now we're going to move over to the next topic of Chapter 6, the last thing we did on Chapter 6, 7, which is graphing. Talking about the concept of graphing a line. There's all different types of graphing that you can do whenever you have various types of equations, but our graphing is just going to be linear equations. A linear equation means you have an x to the first and a y to the first equals a constant, or equals 0, equals anything. So a two-variable equation, both to the first power, is guaranteed to line up exactly in a straight line. So I'm going to show you, for example, this one is not on your study guide, but just to get the thought started, if you had x plus y equals 9, think of all the ways that you can add two numbers, two unknown numbers, that equals 9. A t-table helps us organize our thoughts, to organize these combos, per se. Combos are the coordinates. So one thing that comes to my mind is 5 and 4. 5 plus 4 is 9. So that's a solution to that equation. Maybe you thought of 3 and 6. 3 plus 6 is 9. 1 and 8. 2 and 7. And we could continue on. There's actually infinite possibilities. We could get into the negatives and say -1 and +10. That adds up to be 9. We could do fractions. A half plus 8½ would add up to be 9. 0 and 9 is 9. And the point I want to make is you could do this forever. You could do this. There's infinite solutions to this equation, numbers that add up to be 9. But the neat thing about it is all of these combos will line up perfectly. If you put a stick up here at the edge of your book, they'll line up exactly in a line. I'm going to show you, for example, 5 and 4 would mean go over 5 for the x and up 4. 3 and 6 over 3 up 6. We're running out of room. All right. 2 and 7 over 2 up 7. -1 and 10, that would be back here, -1x and up 10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, let's say. -1, 10. Are you seeing how those are lining up though? And that's what should happen in any linear equation like that. The points perfectly line up. All of these combos and more. And so I put arrows here to show the solutions continue on that way and continue on this way. From left to right, infinite solutions. Also infinite solutions in these little spots even between the integer ones that we think of. There's all kinds of answers. We could say a fourth and 8 3/4, seventh and 8 6/7, and so on and so forth. There's even infinite little tiny spots there. All right, so hopefully I've convinced you a linear equation solutions line up. Most of these have some sort of slant to it, a slope, so we'll talk about slope as well. Notice that this has a negative slope on it. If it goes this direction, we consider that negative slope. Okay, number 28 then is the first problem I'm going to address from your study guide. From graphing, it's y equals 2x minus 3. The directions say to graph this by point plotting. So kind of the idea I just taught you about, just trying to find combos that solve this. Now, you know, if we were in the classroom and able just to pick any number, it would be easier for us. But on Math Excel, sometimes we have limitations, and they want you to pick points that hit a corner, exact corner, so we can't get into the fractional ones. So we will have to maybe shop for a point, try to find some nice ones that fit in our little grid and graph easier. A good starting point is to plug in, say, 0 for x. 0 is an easy number to work with. So if we plug in 0, we get y equals 2 times 0 minus 3. See, I don't know these combos off the top of my head like I did the last problem, so I have to do a little more algebra problems on it. So I'm saying, what if I plug in 0, what would y have to be? Y would be 2 times 0 or 0 minus 3 or negative 3. So check that out. That solution works. 0 for x and negative 3 for y makes these two sides solved or equal. Okay, I need another point. Let's say I try x is 1. Plugging in x is 1, I get y equals 2 times 1 minus 3. Since I don't just know it off the top of my head, I have to work this out. So y equals 2 minus 3 or negative 1. And then I could keep doing that. I could keep plugging in x is 2 or x is 5 and get as many points as you just feel like getting. Also know that you can plug in on the y side. I'll demonstrate that. So again, plugging in x is 2 would be 4 minus 3 or 1. So 2 and 1 should be a common. Now I'm going to plug in on the y side. Let's say I plug in 0 for y. What would that give me for x? So I'd say 0 for y equals 2 times what? Minus 3. So I would throw the 3 across the line by plusing that to each side. So I get 2x equals 0 plus 3 is 3. Dividing by 2, x is 3 half. There's one of those fractions I told you I won't be able to use on the Math Excel program, but that's okay. Then I would just look for other points if I get a fractional answer. So then you'll pick up your graphing tool on Math Excel and you'll plot a couple of those points. I think you only had to find 2 to do this problem, so we have lots. So let's say 0 and negative 3, 0x and then down 3. 1 and negative 1, that'd be over 1 and down 1, and then you can draw your line, and that's the graph of that equation. The graph is a picture of the solutions. Okay, one more. Number 29 for graphing says plot the intercepts. The intercepts are asking you specifically to do the zeros. Plug in x is 0 and plug in y is 0. That's how you find your x and y intercepts. It's still the t-table thought, but with specific zeros. So 0 for x, that's 5 times 0 minus 3y equals 15. And then solve that. 5 times 0 is 0, or you can just mark that out. Divide out the negative 3 on each side. And y is 15 divided by negative 3 or negative 5. So that should be your y-intercept. When x is 0, you find the y-intercept. Now with the other intercept, when y is 0, I find the x-intercept. So do it again. 5x minus 3y is 0 equals 15. Or 5x equals 15. Divide out the 5. We get x is 3. And then you can find another point if you needed to, but if you were careful with your work here, those 2 points should be accurate. Find your graphing tool, plot the 0, negative 5, and 3, 0. Connect those dots, and that's the graph of that line using intercepts. So I'll stop there for graphing.